Welcome to section 2.2, solve one-step equations. Now, when you learned about this in the past, you probably talked about whatever you do to one side of the equal sign, you have to do to the other. What you're actually doing is using inverse operations. So let's say if you have an x plus 3 equals 5, if you subtract 3 from both sides, what you're actually doing is you are using the inverse operation of plus 3, which is a minus 3. And that's why if you do it to both sides to keep it balanced, that's why that actually ends up working out, and we can come out with an x equals 2. This is actually an equivalent equation to x plus 3 equals 5. They mean the same thing, they're just written differently. So those are just two terms that might show up within this section. Now, things we have to look for. Properties of equality. So what can you do for addition that will preserve its property of equality? Well, what this actually means is if you add the same thing to both sides, it preserves its equality. So if you have an x minus 2 equals 3, you can add 3 to both sides. Or sorry, not add 3, you would add 2 to both sides to undo that x minus 2. And as long as you add it to both sides, the equality of the equation will stay preserved. Same thing with subtraction. If you originally had an x plus 5 equals 7, you can now subtract 5 from both sides, and the equality of the equation will stay preserved. And you'll know that x equals 2. The same holds true for multiplication. If you have an x minus, or sorry, not x minus, we need some division here. X divided by 17 equals 3. Well, what you have to do in this case is you have to multiply both sides by 17 in order to actually get this to work out. So what you're left with then is x equals 51. So again, as long as you're multiplying both sides by the same number, it should be fine. Or for division, we could have 3x equals 51. And as long as you divide both sides by the same number, the equality will stay preserved. So that's just a fancy way of talking about what you already know how to do. So let's go and actually do it. So x plus 7 equals 4. We just have to subtract 7 from both sides, and we'll come out with an x equals 3. Or x plus 12 x minus 12 equals 3. We can add 12 to both sides, and we're going to come out with an x equals 15. Not too bad. Let's try some multiplication and division. Negative 6x equals 48. Well, we can just divide both sides by negative 6, and that means x is going to come out to be a negative 8. Or x divided by 4 equals 5. We can multiply both sides by 4, and it'll come out with an x equals 20. So this section isn't actually too bad. Let's look at one more example here. Because when you have a fraction that's being multiplied, to undo the fraction, you just want to multiply by its reciprocal, which means you flip it. And every time I say reciprocal, I'm going to flip my fingers, because every time you hear reciprocal, you should think about flipping the fraction. So we're going to multiply this by 7 over negative 2. And if we're doing that on one side, we need to do it to the other side. So we're now left with an x. And when you multiply by a fraction, you can either multiply across the top and then divide by the bottom, or you can take one of your numbers, divide it by the bottom, and then multiply by the top. So I'm actually going to think of this as 4 divided by negative 2, and then we'll multiply that by 7. So 4 divided by negative 2 will be a negative 2, times 7 gives us an answer of negative 14. And for our final question, this actually comes from the textbook, and I'm going to read it out loud. I just need an abbreviated note here to remind me of what it was. But in the 2004 Olympics, Sean Crawford won the 200-meter dash. His winning time was 19.79 seconds. Find his average speed to the nearest tenth of a meter per second. Well, what that says is even if you just look at the actual speed that we're looking at it in terms of meters per second. Well, that means meters goes on top, divided by seconds goes on the bottom. So 200 meters divided by our number of seconds should come up with our answer of 10.1. So he was running 10.1 meters per second. So that's it for this lesson. So if you have any questions, make sure you shoot me an email, and otherwise, good luck.